Good evening to all. I am Srinivasan Silvaraj from Nirloba IT PRIVATE LTD. Okay. Today we have session on embedded system and IoT. Okay. So see, this is good choice. You are selected to attend this workshop. Okay. I am sincere thanks to your HOD and all your staff who are directed to attend this workshop. Okay, this is a very useful workshop. Okay, definitely after this workshop, you will give feedback that it is very useful. Okay, now say the topic will be embedded system and IoT. Today, everywhere embedded system will be there. Everywhere embedded system will be there. Okay, wherever if you go, if you take your home, your office, your industry, okay, or any shopping complex, if you go to shop any product, there embedded device will be there. Everywhere it is there. Then we should know what is embedded system. Okay, how it is present everywhere. Okay, everywhere. We'll see that now. Okay, if you say embedded system, okay, if you say embedded system, what is embedded system? Okay, first we'll define the what is mean by embedded system. Okay, if you say embedded system, in that one or more microcontroller or processor interface with with sensors to drive electrical and electronic circuits to perform a specific to perform a specific task. So if you say embedded system, in that one or more microcontroller or processor interface with sensors to drive electrical and electronic circuits to perform a specific task. If you take washing machine is good example for embedded system. Okay, it is present in our home. Okay, so washing machine do the specific task, wash the cloth, like that. Air condition, it will maintain the temperature. Okay, my oven, it will boil the material. So embedded system will do a specific task. Okay, so in embedded system, one or more microcontroller and sensor and electrical electronic circuits, everything embedded as a single system to perform a specific task. Okay, so this is the definition for embedded system. See, I said this embedded system is everywhere. See, if you done some courses or if you done some embedded system training, no, definitely you will get a lot of placements. So 2 years back, if you say placement in embedded system means salary will be low and also it's very less. But today, as software engineer, no, how much salary they got, no, same salary, same scale you will get in embedded system and IoT. Plenty of job opportunities there. The reason is everywhere this embedded device will be present. So this device is everywhere means what is the feature or advantage of embedded system? Next will be advantage, okay, or feature of embedded system. Feature of embedded system. See, first, this is designed for automation. The main advantage of embedded system is it is designed to do automation. Automation means to replace human. Okay. So first feature or advantage of embedded system is it is designed to do automation. The second is it is compact in size. Because everything embedded as a single system, so it looks smaller in size. Say if you take mobile phone, okay, we are carrying mobile phone, no, that is a very good example for embedded system. If we are keeping in packet, bag, everywhere, no, we are placing that mobile phone, so compact in size. Next advantage or feature of embedded system is it consume less power. So even using battery, no, or 1.5 volt battery, you can run embedded system devices. So next very important is consume less power. And very important next advantage or feature of embedded system will be accuracy. So accuracy will be there. So it will perform uniform behavior. Okay, if what are the output? No. So suppose the embedded system gives output 5 volt, 5 or 25 means how many times if you run the embedded software or if you switch on the embedded device, it will give the same result. So accuracy will be there. Not only accuracy, with accuracy, this embedded device will will give security for our data, that is information, and security to access our devices. Okay, so this is main feature and advantage of embedded system. Because of this only, embedded device, embedded system present everywhere. So the feature or advantage of embedded system will be: number 1, automation; number 2, compact in size; and number 3, consume less power; number 4, accuracy and security. This is the feature or advantage of embedded system. So if you say in embedded system, I already said one or more microcontroller will be there. Okay, so microcontroller will be there. So we'll see the block diagram of embedded system. This is the block diagram of your microcontroller or microprocessor. So embedded system means definitely controller will be there, microcontroller will be there. Okay, so the first embedded system start with some logic gates, some counters, some timers. Okay, they perform some simple arithmetic logic operations. Okay, using that. After that, they introduce microprocessor. Okay, once microprocessor introduced, then so first they introduce microprocessor. Okay, microprocessor. After microprocessor, they extended to personal computer. First personal computer for office and home use is called XT computer. After that, it is upgraded to AT computer, 82, 86, 83, 86, 84, 84, 86. After that, they introduced Pentium. Okay, Pentium 100, Pentium 200, Pentium 2, Pentium 3, Pentium 4. Now we got this personal computer i3, i4, i5, like that, i5 processor. In between microprocessor and personal computer, they introduce microcontroller. When microcontroller introduced, then everywhere slowly embedded system is applied everywhere. Every embedded system is applied. Suppose if you are going for a shopping complex. Okay, if you say for example a jewelry shop, if you go there, means in the jewel, they will fix RFID tag. So once you select the jewels, then if you take to billing section, they will read that RFID tag, and based on the RFID tag, they will say this is the amount you need to pay. Okay, so immediately you will get the display in the computer, this is the amount you need to pay. So you can make the payment. Suppose if anyone not paid, without paid, if they try to take the jewel outside the shop, means at the entrance of the gate you will have the RFID antenna. So if they are not paid, if they try to take the jewel without paying, means once they cross the exit gate, there will be antenna will be there. That antenna will receive the RFID tag frequency, immediately it will give alarm. So like that, for security purpose also, this embedded device playing very good role today. So once this embedded system is introduced, after that, see, if you say embedded system means one or more microcontroller or processor with sensor and some electronic circuit. Okay, once this is developed in advanced level, then they connected everything on internet. It's nothing but IoT, Internet of Things. So every embedded device and electronic circuits is network in internet. Okay, so that is called Internet of Things. Things means sensor, microcontroller, and other circuits. Even human also becomes things. If the human wears some electronic devices, okay, then the device is connected to internet, means human also become things. So Internet of Things means it's nothing but this microcontroller and everything connected or networked with other devices through internet is called Internet of Things, IoT. Okay, now, so first we know that we came to now, first they introduced microprocessor, after that microcontroller, and it is extended to personal computer. So if you say microprocessor or microcontroller, what you will have in that? What are the sections in a microprocessor or microcontroller? If you see, first we'll see okay about microprocessor, after that we'll see microcontroller. So in a microcontroller, the central processing unit CPU got program counter, arithmetic logic unit, registers, timing and control unit. Okay, then serial port. These sections will be present. Okay, now for this microprocessor, you have to give power supply, clock signal, reset signal. Once you apply these three signals, the processor will start to work. Okay, for this processor, it's a electrical and electronic device. So if you say microprocessor, microcontroller, it's built in by number of gates, number of flip-flops, number of registers, number of timers, number of counters. These registers, gates, timers, registers are built by number of millions of transistors. Using millions of transistors, they built microprocessor. After that, microcontroller came. Now we got personal computer processor also. So if you take any processor, in that you will have gates, flip-flops, timers, counters. This everything built using millions of transistors. Now they are using MOSFETs for that. Instead of transistors, it's advanced level. We are using now MOSFETs. Okay. So for also we know that this microprocessor based on electrical and electronic circuit. For that, you have to apply power supply. The power supply is VCC or VDD. Okay. So when you use transistor, we say operating voltage is VCC. When we use MOSFETs, we say VDD. And next important signal is clock signal. You have to apply clock signal. And next important signal, reset. Once you apply these three signals to a microprocessor, okay, there is a program counter will be there, PC. That counter is up counter. That is, it will count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up counter. And it will count, up counter means from 0 to 10, like that it will go up. So for every clock pulse, the program counter output become incremented by 1. So once you start the microprocessor microcontroller, the program counter will give output. That output will send to address for a ROM. So this microprocessor not only need power supply, it also need program software. You have to write software according to your program, according to your software only. This microprocessor will perform the task. So in that program, you have to say you just blink the LED, you just drive the motor, or you just switch on this circuit. Like that, you have to write program. Okay, that program after writing in a text editor, you compile that source file into machine code using compiler. Once you compile the source code, suppose you are using embedded C, means using a compiler, you compile in compiler, then convert it into machine code. That machine code in hexadecimal format. That X code you download in the program memory, that is ROM, read only memory. Once you download program in the memory, after that if you start the microprocessor or microcontroller, the program counter will send the address. Initially 0000 address sent to the program memory. Once the programmer receives the address, in that location you already downloaded some software or instruction. No, that instruction will come out from the ROM. So that instruction will reach as the instruction register. There that instruction will be analyzed. If it is instruction, then that instruction will go to instruction decoder. In instruction decoder, the instruction will be decoded. That is, it's completely become electrical voltage. Once your instruction is decoded, then the instruction will travel and reaches the ALU, arithmetic logic unit. In ALU only, your instruction will be executed. Once your instruction is executed, in your program, if you say port 0.0, this is a IO, input output pin. So if you say port 0.0, if you make I, means this pin become 5 volt. So that 5 volt through resistance, it reaches anode of the LED. This is LED. So anode of LED is connected to port 0.0. So if you make this pin I, the LED got 1.5 volt. So the LED will on. Okay, this LED will on. Okay, so like that you have to write a program software. Once you write the program, then only based on your program only the processor will do the function. It will not do by itself. It's a electrical electronic device. You have to give instruction. You have to write program. Okay, so this is a basic working principle of microprocessor or microcontroller. First they introduce microprocessor. In that, this ROM, program memory, RAM, IO are external. Okay, are external. So if we say microcontroller, after microprocessor they introduce microcontroller. No, this ROM, RAM, IO built as a single chip. Okay, that is called system on chip, SoC. Okay, so this microcontroller, because of single chip, this microcontroller consume less power. And also for maintenance, for troubleshoot, it's within a chip, everything within a chip. So you will not get you will not get more errors, more faults, because within a chip, it's secured. Every component will be secured. It is packed in as a single package. Okay, using VLSI technology. So you will not get service point. You will not get error. You will not get trouble. You don't need to troubleshoot much harder. Okay, so if anything wrong, you can replace the microcontroller. That's all. You can replace the microcontroller. Okay, so you are doing you are writing some program to do some task. You want to display the result. You can use display. So display is used to display the result. The display may be LCD display, LED display. Okay, touch screen. Today we got touch screens. Okay, so the display section is the output device. That is, port is connected. From the port, the data, whatever you want to display, that message. Okay, from the port it travel to the display. Okay, like that the processor is doing some task. That time you want to feed some information, you want to feed some data. Okay, like your username or password or anything you want to feed. No, so for that you can use keyboard. Keyboard is input device. So if you press any key, then the keyboard will send the scan code to the IO port. From IO port, that scan code will go to the ALU. In ALU you have to write software. If key is pressed, say for example fifth 5, okay, numeric value 5 key is pressed, display 5, or do the task, switch on the motor. If fourth key is pressed, display 4 and do the light on. Like that, if in a keyboard, if you have multiple keys. Okay, so if any one key pressed, one scan code will be generated. Once the scan code is generated in your software, you have to compare the scan code. If the scan code is 1, do this task A. If the scan code is 5, do the task B. Like that, you have to write software. So keyboard is the input unit. So you are doing some task. Okay, you have some result. That result you want to display, you can use LCD. Same time, you want to send the result to another device. Okay, from this microcontroller, using serial port, you can send the data through serial device. Okay, so through serial device, the data will go out from the microcontroller and reaches the another microcontroller or another device. Okay, that is for serial communication. Okay, this is for serial communication. Now we will see one demo. Okay, using RFID technology. Okay, I'll show one demo. Okay, RFID technology for embedded system. Okay, just wait, I'll bring the unit. Okay, so this is RFID tag. Okay, this is the RFID tag. Okay, this is the RFID tag. Okay, which emits radio frequency. This is passive tag. You no need to apply power supply. Okay, without power supply, this is a passive tag. Without power supply, it emits the frequency. Okay, so I am having 3 tags. So each will generate different frequencies. Okay, this frequency using the embedded system. Okay, we are going to display. We are going to convert this frequency into 10 digit number. Okay, that's the project. Okay, for that, here this is one RFID reader, and here one microcontroller will be there. This microcontroller will convert this RFID tag frequency into 10 digit number. Then it will transmit the 10 digit number to this microcontroller, this another microcontroller. So this microcontroller using serial communication, for that only serial communication. So this microcontroller using serial communication, it receives the 10 digit data and display in the LCD. This is the LCD. Okay, display in the LCD. Okay, just we'll see. We'll give power supply. Okay. Okay, so now say I am just showing the tag. Okay, I am getting display of, see here, 4C000421618. No, for this tag, for this tag. Suppose if I take another tag, this is another tag. If I show this tag, okay, here in the reader, no, LED is blinking. If I show, the LED will blink. Okay, okay, LED will blink. Okay, so LED is blinking. No, see, red LED is blinking. Okay, so if you see here in this LCD display, you will have another ID. Okay, 010046A4FB8. Okay, FB. Okay, this is another ID. Okay, this is another ID. So here what happened? This RFID tag will generate frequency. That frequency is converted into 10 digit data. Then that 10 digit data is displayed in LCD. Okay, so this we can use for creating attendance. Okay, if you take in MNC company, no, if you take MNC company, okay, with the ID card, backside of ID card, they place this RFID tag. So once the employee comes in front of the gate, they will show their ID card to the RFID reader. Immediately, reader will read the ID of that employee and it will put the login time of that employee. And while go out, no, the employee wants to go out in the evening time. Okay, if office hours is over, then again the employee show the tag in the RFID reader. It will put log out time. So after 30 days, using login and log out time, they prepare the salary. Okay, like that. I already explained in jewelry shop, no, like this. See, this is like a visiting card, but in jewels, no, they fix the tag. It's like a small size, very smaller size. Okay, that each tag will generate frequency. Okay, that frequency become ID. Okay, it's a 10 digit number or 12 digit number or 5 digit number. Using that ID, they will calculate the jewelry bill payment, everything they will do. Okay, so this is very important in security system. Like that, same RFID tag they use for internal security system of any factory. If you take manufacturing industries, no, if you take manufacturing industries, there is production department will be there, R&D department will be there. Okay, lot of department will be there. Okay, so in manufacturing industries, in R&D department, they will not allow unwanted people. Okay, it's very secured place. So what happened? Whoever working in R&D department, no, that RFID tag only if they show RFID department entrance gate, the door will open. If any other people came and show the tag, means the door will not open. Like that, high level security you can provide using this RFID tag. Along with that, now what happened? No, they want 3-step security. So what today for security system, what they are doing now? One security for RFID tag. Okay, another security fingerprint, another security is facial recognition. So 3-level security they are providing today. Okay, so this is about one project. Okay, RFID system using embedded system. Okay, in this we are using the microcontroller called PIC16F877A. Here this microcontroller is PIC16F. This microcontroller is PIC16F877A microcontroller. Okay, microcontroller. Right. Now, having this knowledge, we'll start to do one project. Okay, we want to display message in LCD display. Okay, and same time we are measuring temperature using LM35 sensor. Okay, so for that first we'll design the circuit diagram. Okay, after that we'll see how to write the program. Finally we'll download the software into microcontroller and we'll see the output. Step by step we'll see. So this is the circuit diagram. First hardware. See, see in embedded system there is a two way. You can write software. After that, based on the software, you can design hardware. Or first you can design a hardware. After that, you start to write software. Any way you can do. Okay, in this we are using PIC16F877A microcontroller. In this microcontroller, pin number 1 is reset pin. Pin number 1 is reset pin. So this pin should be normally high. So for that, from operating voltage plus 5 volt, we are connecting a resistance. That resistance another end is connected to pin number 1. So what will happen? If you apply power supply 5 volt through resistance, it reaches the pin number 1. So at pin number 1 you will get 4.8 because 0.2 volt will drop in the resistance. Okay, so if microcontroller receive 4.8 in pin number 1 reset pin, the microcontroller is ready for do the task. Okay, suppose you want to restart the microcontroller due to some hanging or any other problem, you want to restart, means there is a switch. That switch is called reset switch. So in this reset switch, one pin is connected to ground, another pin is connected to pin number 1. So if you press the switch, ground is shorted to pin number 1. So if the microcontroller pin number 1 become low, shorted to ground means it become low. If pin number 1 reset pin become low, means your microcontroller will restart. So this is the reset circuit, first one. So for any microcontroller you have to give reset signal. Next important signal you want to give is clock signal. So in this microcontroller, pin number 13, 14 is clock input. So to this clock input pin 13 and 14, we are connecting a crystal oscillator, 10 megahertz crystal oscillator. This is a symbol for crystal oscillator. Okay, crystal oscillator, we don't have any polarity. There's no positive and negative. Anyway, you can connect. Okay, so parallelly with the crystal oscillator, we are connecting 22PF disk capacitor. This is the 22PF disk capacitor. So this capacitor is connected, another end is connected to ground. Because of this capacitor, we are filtering unwanted signal, and also we are getting exact clock signal. So see, this microcontroller is a digital circuit. So for digital circuit, clock signal must be important. It should be exact frequency, and also it should be it's fully zero unwanted noise. Okay, then only the microcontroller will do the task. So very important is for any microcontroller, you have to design a good power supply. Okay, it should be completely digital. It's the microcontroller is digital electronics. So you have to give regulated power supply. Okay, you can't use any other normal power supply. This microcontroller needs regulated power supply. The next is clock signal. So once you succeeded clock signal and power supply, then your microcontroller will perform very good. Okay, it will perform in good. Then so pin number 13 and 14 is the clock signal. Next is pin number 11 and 32. You have to connect plus 5 volt, and pin number 12 and 32 you have to connect ground. So you should give, for any microcontroller you should give VCC and ground signal. So once you give reset signal, clock signal and power supply to a microcontroller, your microcontroller is ready for do any task. This is the basic design you have to do first. After that, in our project we are using LM35 sensor. LM30, this you can take screenshot. Okay, LM35 sensor. This LM35 sensor got the 3 pins. Okay, pin number 3 is ground, pin number 2 is the analog output. Pin number 2 is the analog output. So the sensor output will be based on temperature, it will give analog signal. Analog signal means 0 volt, 0.1, 0.15, 2, 2.5, 3, 3.5, like that. It's called analog signal. So this analog signal, you want to do automation using this analog signal. You want to do automation, that is temperature monitor system or temperature control system. You want to do means you need a microcontroller. Okay, but microcontroller is digital, so output of the sensor is analog. So this analog need to convert into digital. Okay, for that in all microcontroller you have the ADC. In this PIC16F877A you have the analog to digital converter. So that pin number 2 of PIC microcontroller is the analog channel 0. So the output of sensor, also pin number 2, is connected to pin number 2 of the microcontroller. So sensor analog output is connected to input of the analog channel of ADC, and pin number 1 is ground, VCC. So pin number 3 of sensor is ground, pin number 1 LM35, pin number 1 sensor, pin number 1 is VCC plus 5 volt, pin number 2 is analog output. That analog output we are connecting to analog channel of ADC of PIC microcontroller, PIC16F877A. So this is the interface between sensor and microcontroller. Power supply is over, reset signal is over, clock signal is over. Now next we want to display temperature in LCD. Okay, so we are using 2 into 16 LCD display. Okay, it's alphanumeric display. So in this LCD display, pin number 1 is ground, pin number 2 again you need to connect plus 5 volt, okay, VCC. Then pin number 3 is a contrast voltage, VEE. That is, see, in this LCD the message will be displayed. Say you want to display hello world, means it display in black color, but it is not exact black, it's called gray color. The darkness of that message, that characters, darkness, intensity, okay, that is based on this contrast voltage, VEE. So normally we should adjust this VEE voltage from 0.6 volt to 1.2 volt, between 0.6 to 1.2. If you adjust to 0.6 volt, means you will get more darker. If you adjust towards 1.2, means darkness will be reduced. If you adjust 2 volt, means it will be less darker. So you want more darker, means you apply voltage 0.6, 0.7 volt. So for that we are connecting on variable resistance. One end we are connected to VCC, another end we are connected to ground. Center of the variable resistance we are connected to pin number 3. So contrast voltage LCD we got, LCD is received. Next is, say in LCD 2 lines will be there. First line, first row, second row, first row, second row. So you can display first row or second row. No, you have to, you should say in your software, I want to display hello world in first line and have a nice day in second line. You want to say. So for that you have to configure the LCD. To configure the LCD, there is a control signal called RS. So this RS pin is a control signal which configure which line where you want to display the messages. Okay, for that RS pin is connected to PIC microcontroller RE0. Okay, RS is connected to PIC microcontroller RE0. Okay, right. So then RE0 is a port E. In PIC microcontroller, you have the port A, port B, port C, port D, port E. 5 IO ports will be there. So in that port E, RE0, 0th bit is connected to RS. And RW is a read-write pin, okay, that is connected to RE1. That read-write pin also control signals, RE1. And LCD enable pin is connected to RE2. Okay, RE2. So port E, RE0, RE1, RE2 is connected to RS, RW enable. Next is, this LCD got the data bus. In data bus only we should send the display which you want to which message you want to display. No, that message, okay, you have to send in data bus. Same time you have to configure the LCD. That command also you have to send in the data bus. So in this LCD you have the data bus D0, D1, D2, D3, D4, D5, D6, D7, 8 bit data bus, this LCD. But out of 8 bit we are using only 4 bits. That is D4, D5, D6, D7. That 4 bits only we are using. That means we are using in 4-bit mode. Say this LCD you can use 8-bit mode or 4-bit mode. We are using 4-bit mode. So for that data bus D4, D5, D6, D7 we are connecting to port B, RB4, RB5, RB6, RB7. So we are using port B of PIC16F877A for LCD data bus. Okay. So the next is, see, this LCD display messages with the background of yellow color or blue color LED. Okay, for that LED, pin number 15, you should connect plus 5 volt. That is LED anode is pin number 15, you connect plus 5 volts, and LED cathode is 16, you connect to ground. So the LED will, background LED will on. So with the background of yellow or blue, you will get the message in black color. Okay, so this is the hardware circuit for interfacing LM35 sensor with PIC16F877A to display temperature. Okay, so I think you understand, okay, how this circuit works. Okay, once you implement this circuit in breadboard, you can assemble in breadboard also, or we have our own boards. Okay, see, actually we are the manufacturer. Okay, we are the manufacturer of development kits for doing your whatever your up to your final year project or industrial applications. Okay, you can purchase boards from us. We are the manufacturer. Okay, we are manufacturing this PIC16F development kit. This is our development kit. Like that, we are we are manufacturing STM32 446RE development kit. Okay, in this development kit, you have the LCD display for your projects, whether it's industrial or your college project, whatever the projects, LCD display is there, sound segment display is there, 2-digit sound segment display is there, serial port, RS-232 port will be there, keyboard interface, here itself keyboard is there, see here, this is the keys, okay, 3 into 4 keys will be there, and this is the RS-232 port, this is the sound segment, okay, and LCD display, here this is the microcontroller, okay, then this is the motor driver, it will give maximum 600 milliamps current, you can drive any DC motor, and LED display. So you want do any task with PIC16F877A, you can use this board. This board cost will be 4,500 rupees, okay, 4,500 rupees. You can purchase up to your final year project or any industrial project you could develop, okay. We will support for developing PCB or whatever you need support from us, we will ready to do, okay. You can call me at 75502 46567. I am from India. Okay, my country code is +91 and my mobile number is 75502 46567. Okay, you can call us for any support you want. We are ready. We are here for doing service to you only. Okay, you can call us. Okay, and also we are providing industrial training. Okay, we are providing industrial training. Okay, you can join the training program also. Okay, for that also you can call 75502 46567. Now, so having this circuit idea, then we will go for programming side. Okay, programming side. This is our development kit, STM32 development kit. Okay, we are from Nirloba IT Private Limited. Nirloba IT Private Limited. See, we are for before going to software, we will introduce our courses to you. Okay, so we are conducting courses on embedded system and IoT in Indian rupee 8,850. Okay, then advanced embedded system and IoT 38,000, and Python programming for 5,000. Python and machine learning 12,500. Core Java 5,000 and C programming 2,200. Okay, so in this course anything you can do. Okay, so we are from Nirloba IT Private Limited. You can take screenshot. Our mobile number will be +91 75502 46567. Okay, so you just call us. This is a WhatsApp number. You can WhatsApp also. We will respond you. We are ready to service you. We are ready to service you. Anytime you can call us. Okay, now we'll go to the program. So this program we already typed. Okay, to save the time, we will just go the program. The program is temperature monitor. These are the projects. Okay, so temperature, here temperature monitors come. This is the program. You just click the program. So I will take the diagram also. Okay, so now we'll take the program. So this is a program. Okay, we'll keep like this software and program. Okay, so this is temperature monitor is the name of the program. We have to type in text editor. that is you can use notepad and save it temperature monitor.c. This is our program. Now first statement in our program will be as defined LCD underscore RS underscore pin. Okay, that is LCD RS pin, no, this RS pin in LCD. Okay, pin number 4 is connected to RE0 port E0 that you have to implement in software. So the command will be as define RS underscore as define LCD underscore RS underscore pin is connected to pin underscore E0. E0 means RE0. The next is as define LCD underscore RW underscore pin is connected to pin underscore E1. RE1. See here, RE1 is connected to RW. Next will be enable is connected to RE2. So you have to do as define LCD underscore enable underscore pin is connected to pin underscore E2. Next is data bus D4, D5, D6, D7. No, D4, D5, D6, D7. Okay, so D4, D5, D6, D7 data bus. Okay, so as define LCD underscore data 4, that is D4 is connected to pin underscore B4. So in this D4 is connected to RB4. The next will be as define LCD underscore data 6 is connected to bin underscore B6. So in diagram RB6, okay, RB6 is connected to D6. Then next is data bus D7 as define LCD underscore data 7 is connected to pin underscore B7. So D7, this is the D7, pin number 14 is connected to RB7 of PIC16F877A microcontroller. This is the PIC16F877 microcontroller. So you have to implement whatever hardware, how you are interface with your microcontroller with LCD, no, you have to implement in the program. So first as defined statement will say how your LCD control signals and data bus connected to PIC microcontroller IO port. Once definition is over, the next is your program starts. First in embedded system you have to include the microcontroller header file. So as include system877A.h. We are using PIC16F877A microcontroller, so we are including the header file. That's the first statement in embedded C. And then as features HS means high speed. We are using 10 MHz crystal oscillator, so it is high speed. HS, no WLT. We are not using watchdog timer. See, there is a timer called watchdog timer. The function of the watchdog timer will be if the processor, if the microcontroller not doing anything, it's not performing anything for a particular time, okay, up to particular time means immediately it will restart the microcontroller. You say we are doing only LCD display, we don't want watchdog timer, so no WLT. And no product means I am allowing other people to copy this code, this software from microcontroller to another microcontroller. So no product. Okay. Product, if you put product means no one will copy your code from your microcontroller. That's for production. No LVP means we are using 5 volt for programming. So we are not using low voltage programming. So no LVP. So second step in the embedded system will be how you are going to program the software into the flash program memory. That the process is called fuses or burning or flashing. So I am going to fuses my program memory ROM, okay, using HS, no WT, no product, no LVP. After that I am saying as defined ADC equal to 10. That is in this microcontroller you have the analog to digital converter. That analog to digital converter only convert sensor analog signal into temperature using analog to digital conversion. So that ADC result will be 10 means 10 bit. Okay, 10 bit. Then say for my program I want some delay. Okay, I want to display temperature monitor for 300 millisecond means I want delay. So as use delay clock equal to 10 megahertz. See, I am using 10 megahertz crystal oscillator. So I am saying clock equal to 10 megahertz. Then as include lcd.c. I want to use lcd.c file for my program. So this lcd.c file will be in this compiler, CCS compiler. So I am including that lcd.c. Then next is I am declaring the array. Next will be I am declaring the array. So character temperature is array. I am declaring the value of double quote starts. First digit will be blank. After that second digit will be 0. Third digit will be 0. After that decimal point. After the 0. After the blank. Say this LM35 sensor using LM35 sensor you can measure temperature from minus 55 degree to plus 150 degree. So if the temperature is above 99 degree means this here first digit will be blank. So if the temperature is above 99, that is from 100 means first digit will be 1. Okay, other digits we can take it from ADC. So for that reason only first digit I am making blank. Then I am declaring another variable, unsigned integer 16 temp. Temp is another variable. Now main program starts, void main starts. Okay. First you have to configure the ADC. So for ADC, you have to give clock signal, conversion clock signal, and you have to give start of conversion. Then you have to select the channel. See, in this microcontroller, you have the 8 channel. 8 channel means you can connect 8 sensor. But in 8 channel means channel 0 to channel 7. Channel 0, channel 1, channel 2, channel 3, channel 4, channel 5, channel 6, channel 7. In that, which channel you are going to use, that channel you have to select. So first you have to give clock. So setup underscore ADC, this function will set the clock. The argument will be ADC underscore clock underscore internal. We are using internal clock for ADC. The next is conversion clock is over. Okay, then we want to make the channel as analog. So setup underscore ADC underscore force AN0. So we are making AN0 channel is analog application. The next is setup underscore ADC underscore channel 0. So in channel 0 only, pin number 2 is channel 0. In pin number 2 only, see here, in pin number 2 only, this is pin number 2 is channel 0. In pin number 2 only, we are connecting LM35 sensor output. So LM35 output is pin number 2, is connected to pin number 2 of the microcontroller. So we are using channel 0. That channel in our software we have to select. So set underscore ADC underscore channel 0. We are selecting the channel 0. That means sensor analog signal get into the analog channel of the microcontroller and it is converted as digital. Okay, for that only. So now LCD underscore init. We are initiating the LCD. In LCD only we are displaying the temperature. Then LCD put C/F. /F means it will clear the display. See, the best practice is you want to display any message in LCD means first you have to clear the LCD. So for that only LCD underscore put C/F. Your LCD will be cleared. After that we want to position the cursor. See, in LCD you have the two lines. Line row 0, row 1. That is line 1, line 2. You have to position cursor where you want to display. So I am positioning the cursor LCD by the command of LCD underscore go to XY 3, 1. That means third column, first line. I am selected first line. Two lines will be there. I am selected third column in that first line. First line I selected. In that first line, third column I selected. Then after that printf, I am going to display what I want to display. No, LCD underscore put C temperature. I am displaying temperature. Okay, in first line temperature. Then while true, always in loop. Okay, delay underscore ms1000. Up to now what I done, I selected the conversion clock for ADC and I make the channel as analog and I select the channel 0. After that I clear the display. After that I display temperature in first line. After that delay underscore ms1000, 1000 millisecond temperature will be displayed. After that I'm saying temp is a variable. I declared integer 16. Temp equal to read underscore ADC. Say this is read underscore ADC is a function which convert analog temperature sensor analog signal into digital. Okay, the digital value we want as a temperature in centigrade. So the digital value need to convert in temperature. For that I am multiplying by into 0.489. If I multiply by 0.489, then the digital value is converted in temperature. It is in centigrade. So the 0.489 I am getting 500 by 1023. 1023 is 10 bit ADC. 500 is nothing but 5 volt. 5 volt. So if you multiply digital value with 0.489 means the digital value is converted into temperature, that is centigrade. Okay, now if temp, see in temp we got the temperature in centigrade. If temp is above greater than 99 centigrade, if the temperature is above 99 means what will happen? First digit, see this is array, temperature array. In that only we are storing the temperature in centigrade. So if temperature is above 99, that is 100 degree means first digit will be 1, no? 1, first digit will be 1. So temp, if temp greater than 99, temperature of 0, see this is a temperature 0, temperature of 0 is, index of 0 is first digit equal to 1 plus 48. That means 1 is the decimal, plus 48 means it become alphanumeric character, ASCII character. So ASCII character only you can display in the LCD. So 1 plus 48 means 1 will be displayed in the LCD as first digit. Then if it is not greater than 99, it is below 99 means first digit will be blank. So temperature of 0, if it is below, else if it is less than 99 means temperature of 0 is blank. Then say first digit I got, then I need second digit and third digit. Okay, maximum is 155. First digit is 1, maximum is second digit will be 5 or 0, maximum 150. So first digit I got it, second digit, third digit I need. Where is that? It is in temp. So it is in temp. So temperature of 1 is the second digit, temperature of 0 is first digit, temperature is array. In that temperature of 1 is the second digit, equal to temp divided by, temp is the digital value in centigrade, temp divided by 10 moles of done means you will get the second digit, plus 48 means the decimal become ASCII character, you will get display in the LCD. Okay, this I can explain in Python. If we go to in Python, okay, in Python, say I am saying x equal to 125. Okay, now I want 2 alone. I want to take 2 alone means integer, okay, x, I am converting x divided by 10 and I am doing mods of 10. If I do this, I will get 2 separately. Okay, so I want third digit. I want third digit means x integer again x, okay, then mods of 10. If I do, I'll get 5. Okay, so same principle here I am applying. Temperature of second digit will be temperature of 1 equal to temp divided by 10 moles of 10 plus 48. Second digit I'll get it. And temperature of 2, third digit equal to temp moles of 10 plus 48. Third digit I got it. So first digit I already got, second digit I got, third digit I got. So I stored in temperature of 0, temperature of 1, temperature of 2. So now in temperature of array we got the temperature in centigrade, and temperature of 5. Temperature 5 means year. In between this year, this is the temperature 5. See, this blank is temperature 0, temperature 1, temperature 2, decimal is decimal point is temperature 4, and 0 is temperature 5. Okay, see, sorry, temperature 0, temperature 1, temperature 2, temperature 3, temperature 4, temperature 5 is blank. So temperature 5 equal to 223. If you send 223 to LC display, it display degree symbol for that only. So degree symbol. Then now I calculate the temperature and I substitute the temperature into the array. Now I want to display. So LCD go to XY. Already in first line I got the temperature. I display temperature. Now I am pointing the LCD cursor. LCD go to XY 5,2. 5,2 means fifth column, second line. First line temperature is displayed. In second line I want to display the temperature in centigrade. So printf LCD underscore puts it temperature. Temperature array. In that temperature in centigrade is there. So immediately I got the display in LCD. This is the way you have to write software for any project. Okay, first you see how I follow. First I explain the hardware, then I explain the circuit. Once successfully create the hardware, then I come to the software side. So like that you can work out. See, in some advanced level, what happened? No, already they develop the hardware or already they develop the software. Based on the software, they ask you to design the hardware. See, in embedded system, if you say as a embedded C programmer means if you know software is enough. If you say embedded system engineer, you got job in embedded system engineer means you must have knowledge in both software and hardware. Both software and hardware. So whatever the way you can, the best way is after designing hardware, if you go for software, your job will be will be quick. You can finish the job with a specified time. Okay, it will not take much time. Okay, and also it's look easier one. Okay, so once you download this, once you create your software in compiler, the next see, we want to download this program, okay, into microcontroller. Okay, so this is our development kit. No, so in this development kit, this is the PIC16F877A microcontroller, 40 pin IC. This is the PIC16F877A microcontroller. So I want to download this software, okay, this software into this microcontroller. For that, I need a programmer. Okay. So this is a programmer. Okay, PIC2 programmer. In this microcontroller, the curve will be there. This is a pin number 1. Okay, so here in this programmer, this is a SIP socket, 40 pin socket. Here this side is a pin number 1. Just connect here this pin number 1. Okay, and lock the SIP socket. You lock it. Okay, if you done properly, then it will work. Otherwise, it will give some loose connection. So I inserted the microcontroller in the programmer. Then this programmer need a cable. Okay, this program should connect to USB port of our laptop. So this is C type cable. I just connect this. Okay, one end of the cable I connect the programmer, another end, this is another end, I connect to my USB laptop. Okay, it is connected. Once I connected, see only one LED blowing in a green color LED. Okay, now in the after typing the program in compiler, then you just compile. If you do compile, okay, if there is no error, then it will show build successful, zero error, zero warning. Suppose if I missed one semicolon here, if I missed one semicolon, and if I compile, build fail, one error. So on line number 21 is the error, line number 21 expect, okay, semicolon. So whatever the error, no, you will get it in message. So here this is the line number 21, it's red line, before that semicolon is missing. Then you, after that you just type the semicolon, and if you compile, it will say no error, complete no error, and it display build successful. So once you build successful, then you will get, see the program name is temperature monitor C. Okay, then once you compile, you will get temperature monitor .x file. Okay, this is C file, you will get X file. That X file only you have to download, okay, into the microcontroller. This is the programmer I already shown. So here I am using MPLAB ID. Software is needed for the programmer, so I am using MPLAB IDE. This is another IDE. Okay, you can use as a compiler also. Okay, this is very good IDE, MPLAB IDE. Okay, then in that MPLAB IDE, for programmer part, go to programmer and select programmer. So here lot of programmers are there. In that our programmer is PIC2. Select PIC2. Once you select, say another LED is blowing. No, earlier only one LED. Now we got another LED, two LEDs on. Now here we are getting display PIC2 ready, and PIC16F877A found. We just insert the microcontroller is there in the programmer. Now we want the file. Okay, then go to file menu and select import. Okay, import, and in training our project name is temperature monitor. No, so that X file you have to take. See, temperature monitor, this the temperature monitor, this is the X file. So after compile, you will get this X file, then select the X file. So now loaded embedded training temperature monitor X. Okay, now once you downloaded, then go to programmer, you just click program. See here red LED is on. No, okay, so now verifying configuration memory, pick it to ready. Now your program is downloaded into the program memory of the microcontroller. Now the software is inside the microcontroller. So the software, so once you download successfully your software, then take your development kit. Okay, this is our own development kit. Say we are manufacturing the development kit for your projects, for your projects, whether it's in industrial or education. You want any development kit, means you can call us at mobile number +91 75502 Say our mobile number will be 75502 It's a WhatsApp number. Our country code is +91. See, I am calling from India. Okay, I am from India. My mobile number is 75502 My country code will be +91. If you are abroad, you just call or using WhatsApp number +91 75502 Okay, so this in this development kit, just insert this PIC microcontroller. Okay, then for this microcontroller, power supply is needed. Okay, power supply is needed. So I am using 12 volt DC adapter. 12 volt DC adapter. You just take this DC adapter. Okay. Here, this is the power supply connector. This is the power supply connector. Just I inserted the power supply. So here I am getting display of first line. I am getting display of temperature. Okay, temperature. Now the temperature is, see here the temperature sensor may be loose connection. So it will give randomly. I have to insert this. Okay. Now my room temperature will be this 44, not 44. Okay, some loose connections 26 to 29. See here, 29. 29 is my room temperature. So temperature 29 degrees centigrade. Okay, now we got the output, no? So this embedded system, how many times you run, if you don't have any loose connections in your hardware, and you write the exact code, how many times you run, you will get the same result. Okay, that is the accuracy. So the advantage of embedded system will be, number one, automation. With automation you will get accuracy. With accuracy you will get speed. With speed you will get security. With security it consumes less power and compact in size. This is the advantage of embedded system. So because of these reasons only, everywhere embedded system will be there. So if you select your carrier on embedded system, means you will get a best feature. There's no doubt at all. Best salary and best feature. Okay, a very good scope for embedded system and IoT. So we are giving professional training on embedded system and IoT. Those who are interested to join on embedded system and IoT, you can call us 755024657, and our country code is +91. If you are abroad student, you just call by +91 755024657. And also another important scope of in future will be machine learning. We are giving 100% what industrial need. That training we are providing in machine learning, Python and machine learning. That course also is there. You can join that course also. Or you want to start freshly you want to start your career in programming, means you can join our C++ program. So whatever your requirements, you call us at 755024657. We are from Nirloba IT Private Limited. Okay, thank you. Thanks for coming. If you have doubt, if you have any doubt, you can call us. You can ask me now. If you have any doubt, you can ask me now.